Hi, this is some laboratory prep for our next lab, which is on graph matching. We're going to be using a new piece of equipment. This is called a Go Motion from Vernier Software and Technology. It's a motion detector, and it works a lot like sonar. It sends out sound pulses, and they bounce off objects and come back, and then the computer can measure the time difference between the sending and the echo, and it can then plot position and velocity and acceleration and other quantities. So that's what we're going to be using. Let me try to show you how it works. We'll need a laptop to connect it to with a USB cable. And maybe you'll be able to hear it clicking. It's clicking. But it's pointing at a wall, so it's reading a nice flat line. I'm not sure if you can see that on the screen. Let me try to walk in front of it, because what we're going to be doing in the lab is there will be a graph on the laptop screen that you're going to try to match. So we'll set it up on the table so that it points, it has a top that goes up and down like this. So we'll point the detector at the person that's walking, and we'll hit collect, and we'll move forward and back, and we'll try to match the graph that's on the screen as you go along, as you walk. I would recommend walking backwards so that you can see the screen to see if you're matching what the computer wants you to match. And so to prepare you for this, I would like you to answer the preliminary questions tonight at home. And those preliminary questions are on the lab sheet, but you don't need the lab sheet, you can just do it right here with that. It asks you to predict what these four circumstances would look like on a position time graph. That is, an object that's at rest, an object that's moving at constant velocity in the positive direction, an object that's moving at constant velocity in the negative direction, and an object that starts from rest and has a positive acceleration, that is an acceleration in the positive direction. You may need to review the video from before about graphs, motion graphs. If you recall from that video though, if the object is at rest, that means its position doesn't change with time. So any line that's horizontal would indicate an at-rest thing on a position, an at-rest condition, sorry, on a position time graph. If it has a constant velocity in the positive direction, that means the position is getting more and more positive in a constant way. And so you should have a positive slope. So after doing those two together, you need to tell me what a constant negative velocity looks like on a position time graph and what a constant positive acceleration looks like on a position time graph. That's a tougher one. The next four questions are pretty similar, except they deal with velocity time graphs. And we'll be switching from position to velocity time graphs in the lab. And so you're going to have to switch mindsets about how you think about what motion is being described on a velocity time graph. Same four conditions: at rest, constant positive velocity, constant negative velocity, and constant positive acceleration. But now we're doing them on a velocity time graph. So it's your job to predict what those will look like. We'll do the first two together again. If it's at rest, then what is true about the velocity? It's zero, and it stays zero because it's at rest. So that's what a constant velocity at rest is on a velocity time graph. And if it's a positive velocity, that means we're up above here, up above zero, not below zero. And it's constant, which means the velocity doesn't change. So again, it's a horizontal line, but it's a horizontal line somewhere where the velocity is positive. It's your job to do these other two, and don't forget about the position time graphs as well. That'll prepare you for the lab, and then we'll have fun in the lab matching the graphs.